Good afternoon, everybody, and welcome back to Stage 3. I am pleased to announce our next speaker, Leila Bougria, with her session, Mirror, Mirror on the Wall, Am I a Critical Thinker After All? Which is a great title, by the way. Leila is a software engineer at Particular Software with over 15 years of experience in the net space. Hi, Leila. How are you doing?
Hey, Tess. I'm good. How are you?
Great. I'm fine. Thank you. Now the stage is all yours. I don't want to steal your time. So.
Cool. Thank you very much. Well, welcome, everyone. My name is Leila. You'll have to excuse my voice a little. I'm still recovering. I've been trying to recover for over a week, but it's a bit deeper than usual, so it's fine. You can find me on all the socials if you'd like to connect or ask more questions after the session as well. Now, I've been a software engineer and architect for almost 2 decades at this point, and I worked on plenty of different projects and systems throughout that time. So I feel pretty blessed to look back and say, some of them were really successful. They're still running in production, they're being actively maintained, the code base was solid. And you would always like to go back and change something, right? But all in all, I'm pretty proud of the result that our team was able to achieve within the limits and the time that we had at the time. And there's also a couple of projects that, they weren't bad, but they weren't memorable either. Things worked more or less, and the design and code were also more or less, like, not bad, not terrible, just less memorable, I suppose. And then finally, there's this one range of projects which just haunt me. They still haunt me to this day. These code bases that had some terrible hidden monsters, sometimes not even that hidden, right? That still give me the chills when I think about them. And I'm going to share with you one specific example from my own experience. I remember joining a small team for a project. Actually, the system was already live, was already running in production. They were really happy with it and they wanted to extend on it further. So I remember opening up this code base and seeing, okay, as a way to get data in and out of the database, they're using an object relational mapper. In this case, that was NHibernate. Fine, great. They were also using some store procedures because they had optimized a couple of queries, which is also fine. And then looking a bit further, I found some hard-coded SQL in there, which was like, yikes, that's not really great, right? But okay, we could carve out some time and refactor that out. But what was really so terrible about this project is that they used a second object relational mapper. Now, I'm not talking about 2 different components that participate in a larger system that each had their mechanism to get data in and out of the database. This was a single monolithic application, right, with 2 ORMs. Now, this was really hard because in order to query entities, you basically had to understand, through which ORM are we managing this entity before you could then understand which type of session that you could use to get that data. Now, with time, this became worse because sometimes we needed to join certain entities that were managed by NHibernate with entities that were managed by Entity Framework code. And what happened is that basically they duplicated the entities in code. I mean, I think you can imagine the mess, right? We got to a point where it took a 1-hour analysis to be able to query some information from the database or figure out how we would get the data in the database. And I'm sure we could spend a whole day sharing and talking loads of different of these horror stories, if you will, and probably laughing and crying a bit too. But what I'd rather focus on for this session is trying to understand why it happened in the first place. And there are many reasons that can cause this aftermath that we sometimes face. And one major reason is that many of the decisions that are made happen unconsciously. People don't always necessarily realize that they're making an impactful decision in the moment, but then with time, it tends to have a bigger impact than they had anticipated initially. Then there are also some changes that slip through without evaluation, without questioning, or even without reviewing, right? And then by the time it's noticed, it was like a weed that started to grow so large that it became unmanageable and hard to reverse, at which point it's like, well, let's rewrite, right? But it could also be that there's an insufficient evaluation of priorly made decisions. So maybe we are mindfully making decisions, but then once it's decided, we never change, even though our context changes and our entire situation changes. There seems to be this sort of reluctance to changing something that had already been decided before, and we continue using things that are not fit for purpose. It could also be that we're facing decisions that are made by an authority. That could be a software architect, a tech lead, a CTO. It doesn't even matter. If there's no direct connection between the team that is supposed to then implement those decisions and someone else is making them, sometimes you see a lot of teams just struggling and seeing things that aren't fit for the thing that they're trying to achieve. And that can also cause a lot of friction and a lot of terrible code, if you will. Another example is what I like to call CV-driven development, because engineers get excited about technology, right? We love technology, and we go to conferences, we learn about technologies, and then we come back to work and super eager to start using all of those things. And is it then really, really needed? Is it fit for the project that you're working on? Well, I don't know, but it would be so much fun, right? And then finally, there's also copy-driven development. And I'm not referring not even necessarily to copying code, although that also brings its risks, of course, but also copying previous behavior, right? We used microservices in the previous project and it worked so well, so we're just going to do that again. But what if your context is entirely different, right? So it's also important to consider, is that going to be overkill? Is that going to be insufficient? Now, luckily, there are things that can help us, and one of them is critical thinking. Now, my observation is that most engineers would consider themselves critical thinkers. And that does make sense, right? I mean, we work in a very complex industry and we're facing difficult multi-angle problems all the time. I used to think that I was a very good critical thinker because I always, was always curious, and I like to understand why we did certain things and how we did certain things. So I had that sort of curiosity already in me, and that's what made me believe that I was a critical thinker. Now, the thing is that then I joined the company where I'm currently working, which is Particular Software, and I was faced with a structured process to apply critical thinking when making decisions. And I wondered, why is that needed? Why do we need all of these structures? So I started to look into critical thinking as a subject. And I came across this definition on Wikipedia. So I started to read through that, and I was like, so do I always analyze all of the available facts and evidence, observations, and arguments before I form a judgment? I don't know. Am I always rational and skeptical and unbiased in my analysis and evaluation? Maybe. And I wasn't really trained or educated in critical thinking either. I mean, the thing that came closest is probably learning about scientific method in high school. But I hadn't really practiced any of this throughout my career as a software engineer, as an architect. So at that moment, I took a step back and took a good look in the mirror and had to admit to myself that up until that point, I wasn't really a critical thinker at all. But there's good news as well, because I strongly believe that any one of us can become a critical thinker. And it's actually a highly valuable skill in such a fast-moving industry where we're being faced with new technologies and architectural styles and patterns and practices and options to choose from when we build systems. And that's exactly what this talk is about. So let's take a look at which building blocks that we need to effectively apply critical thinking when we make decisions. Now, there are a couple of building blocks that we are going to go through. Don't get too focused on them just now already. But what I will basically do is go into depth on each of them. And what I will do is I will circle back to my multiple ORM story, the horror story that I faced earlier in my career, and try to make them a little bit less abstract and apply them so that we can get a deeper understanding. So let's start at the beginning with the problem statement. Now, this is often overlooked, but I feel it's the most important step really to ensure that we're making the right decisions. First, we need to figure out whether we're solving the right problems, right? As Gilbert Chesterton, a famous English writer and philosopher, once said, it isn't that they can't see the solution, it's that they can't see the problem. And what really struck me about this quote and why it resonated with me is that as engineers, we experience this all the time. Because what is the hardest part about fixing a bug? It's understanding the problem, the scenario in which the fault occurs, and all of the variables that lead to that specific situation to occur. And once we understand all of those variables in that context, usually fixing the bug is quite trivial at that point. And we experience this all the time because all of us have fixed bug at some point in our career, right? But we don't see that and then go and apply those learnings when we decide on our software architecture, implementing new features and design decisions that we make. So we need to pause more often and ask ourselves, what is the problem, right? Now, identifying the problem may sound simple, and it is simple, but it is not easy. Those things are not the same, right? It's actually quite hard, especially for someone who's technical by nature, a software engineer, a software architect, because we are basically hardwired to jump into solution mode. We are biased towards action, right? And actually, my observation is that if you look at most backlogs, right, most issues that you'll find in a backlog are proposing solutions, and they're not really discussing problems. So we need to take a step back and write down that problem statement in simple terms. And with simple, I mean in a way that almost everyone would be able to comprehend it. Just a single paragraph doesn't have to take, a whole lot of time. But what's really important is that it doesn't contain any solution proposals, because that would undermine any attempt to think about the problem, because we're already in solution mode, right? Listing potential approaches and solutions also is going to bias our thinking towards those options and anyone who would be reading that issue as well. Now, another thing that I'm also allergic to, as I say, is to frame those problems using technical terms. Because the reality is that most problems that we need to solve are not of the technical kind, right? We're solving business problems and using technology to do that. So the problems that we are solving are not usually technical. So if you find yourself using a lot of technical lingo to describe the problem, then you should be digging deeper and asking yourself what the underlying problem is that you're trying to address. I find that the 5 whys technique can be helpful here, where you just keep asking yourself a couple of times to find the root problem that you're really trying to address. Now, framing that problem is one thing, but it's also important to pay attention to how we frame it. Because as we all know and continuously ignore and underestimate, words have power, right? How we frame something, what we choose to emphasize, and the nuances that we place in our wording, that has a significant impact on the applicable solution space of a given problem. And a great example of this is the slow elevator problem. Now imagine that you own an office building, right? And you're receiving complaints about the elevator being slow. Now a valid problem statement for this issue would be to say, the elevator is too slow. An equally valid problem statement would be to state, the wait time in the elevator is really annoying. Now, this difference may seem irrelevant at first, but it really has a huge impact, because the problem framing here is opening up the applicable solution space. Now, even without naming any solutions in any of the 2 problem statements, we are already forcing whoever's looking at that into a specific solution space. Now, what do I mean by that? Well, that first problem statement was presented to a group of people, and the options that came up was, well, why don't we just upgrade the motor? Or why don't we adjust the algorithm? Or maybe we should just replace the motor entirely and just upgrade it to a completely new model, right? But that second problem statement, that actually opened up completely different options. For example, someone said, well, what if we would install mirrors in the elevator? That would keep the vein amongst us busy, right? Now, we could also, for example, install a TV and show some news or show the current weather or whatnot, right? The thing is that if the wait time stops being annoying to the people riding the elevator, hasn't the problem really been addressed? Did we really need to make the elevator faster? So one of the important components that I find missing from that first problem statement is the stakeholder's angle, the person that's riding the elevator. And a problem statement is therefore incomplete if we're not aware who is affected by that problem. Now, in order to understand that, we first need to figure out who our stakeholders are, right? And this could be anyone who is directly impacted by the outcome of your project or is heavily involved in it. That could be users, it could be customers, Sometimes they're the same group, sometimes they are not. So that's important also to keep in mind. Or it could be, the engineering team, product managers, financial stakeholders, and so forth. Now, the good thing is that this is going to be a one-time exercise, because unless you completely change your line of business, stakeholders tend to remain stable over time. Now, what's important is that they may have conflicting interests. Again, that is why it's so important to understand who the stakeholders are, so that we can balance the solutions that we choose across those conflicting interests as well. We don't want to solve one problem and introduce 5 other ones because we didn't realize how that negatively affected someone else. Now that we know who they are, we also need to understand their needs so that we can solve the right problems, right? And in order to do that, we need to talk to them. Of course, Laila, we need to talk to them. But the thing is how we talk to them. Because one of the big challenges is that stakeholders don't always fully understand exactly what it is that they need. Because what happens is that they will ask you for certain features because they are also going into solution mode, and they are also thinking within the boundaries of what they think is possible within the system that they are working with. So it's important that we also rephrase the way that we ask our questions, and rather ask questions like, what goal are you trying to accomplish? Or what friction do you experience? Why does that bother you? And what are you trying to accomplish? And in which context does that occur? And from those conversations, we basically want to try to identify the need and then validate it with them throughout those conversations, and also write it down. And when we write it down, frame it from their perspective, because that also helps anyone working on the team to also better understand, the stakeholders and their needs and their own perspective, right? So once we have that figured out, we can go back to our problem statement and ask ourselves, so to who is this actually a problem? And if we solve this problem, which needs are we addressing by that? And also, are there any conflicting needs that are connected to the problem that we're trying to solve, right? This will also help us validate possible solution further down the line as well. Now, if I go back to my horror story, right, and we try to apply this, it just proves how important it is to slow down and to think about the problem, because in this specific case, the reality is that there was no real problem being solved. There was absolutely at the time no valid reason to introduce a second object relational mapper into that code base. This was a clear case of CV-driven development. Of course, with the best intentions, right? The person who did this had the full intention of replacing the whole thing, but the reality is, or the reality kicks in, is what I should say, right? It kicks in and you have deadlines and you're out of budget and this feature is more important right now and the customer is waiting, or there are issues happening in production. And then, we'll do that tomorrow. And with time, that becomes a huge problem. Now, for the sake of the example, so that we can continue building upon this throughout the session, let's assume that there was actually a problem to solve. Let's say that there was a change to the organization's compliance policy requiring us to only use software vendors that actually offer support agreements. So we could say, a problem statement could look like this. The application uses dependencies that don't offer formal support offering and are therefore not compliant with the organization's policy. Now, we also need to connect that to the stakeholder, and the main stakeholder in this story is the organization, which in the context of building software systems needs to exclusively select dependencies that adhere to that compliance policy that they have, right? So now we have that problem statement connected to the needs. And then we are ready to start looking at possible solution and evaluating multiple options. Now, what is important right here is that we think outside the box. Now, it's important to take some time to think about options beyond the 3 options that just come to our mind when we are looking at a problem, and challenge ourselves to look beyond what we think is possible based on our previous experience and based on our educations and so forth. Now, I realize how easily that is to say and how difficult it is to do, because how do you think outside the box? How do you even know where the boundaries of your own boxes are, right? And I found that one of the most powerful ways to think outside the box is to actually do the work in a collaborative work with a diverse group of people. Now, there are multiple studies that have already shown how diverse team improve the outcome of many, many different projects, including software projects as well, right? But for this specific session, I'm not even referring to diversity in terms of gender or race or what it is, although they're very, very important. But in this case, I'm specifically referring to diversity in professional experience and education. People who come from completely different mindsets, completely different ways of thinking, and different educations, right? Because the thing is that if you put a group of engineers together to look at a problem, they're all going to present you with engineering specific solutions. But if you bring in people with other capabilities, with business expertise, with maybe an HR specialist or testers or graphic designers, the results might actually surprise you. And this is actually further backed up by the elevator problem, because when we think back to the options that were proposed, upgrading the motor, improving the algorithm, those were solutions that were brought up by the engineers that built the elevator. But then the options about, oh, let's install a mirror, that came from the building managers. And that really shows you the power of diversified thought. Now, of course, it's also important to have a balance. You can't just, I understand that you can't just sort of invite the entire organization to every problem that you need to solve, right? And also that would just cripple you because you'd have way too many different opinions and that would slow you down to a point that it's not manageable. But having a little bit of diversity there is really, really important. Now, when you do that, and this may seem obvious, but in my experience, it's not, it's important that whatever team that is doing this also welcomes different and opposing opinions, because that is easily said. But when someone shakes your foundations like that and your core beliefs, it is something that takes getting used to. But it's important that everyone that is invited to the conversation feels sufficient trust and sufficiently empowered to actually share their honest opinion as well. Now let's apply this to our horror story, right? We gave this problem to our engineers to evaluate options, and they came up with, well, let's just go from Hibernate to Entity Framework Core then, because that's supported by Microsoft, and then we don't have any issues again with our compliance policy, and we're all good. Or another option that we could choose is to maybe build up the knowledge of the Hibernate code base internally, and then we would be supporting the code base. That would work, right? But then you would pull in someone that is involved, that has some financial decision-making power, and they could say, hey, why don't you reach out to one of the Hibernate maintainers and ask them whether they're interested in setting up a support contract with us, right? And then you pull in someone that has knowledge of the internal compliance policy, and they might say, so wait a second, what type of application is this? Is it mission critical? Does it contain any sensitive data? Well, then maybe what we could do is adjust the compliance policy to exclude these types of applications, and you don't need to change anything at all, right? Now, the thing is that those two bottom options, right, they're not going to be commonly identified by engineers because it's way outside of their box. It's way outside of what they even think is possible for them to consider, right? So having that diversified thought is really going to be really powerful when you're looking into possible solutions. And then we need to assess whether each individual alternative is actually a viable alternative or not. Now, how do we do that? Well, we need to start by gathering facts and data. Now, to ensure that we're making rational decisions and not emotional ones, we need to have some data to back up what we're saying as well. Now, we have a typical human trait, right? We will feel a very strong pull in one specific direction, usually your own proposal. This is also called confirmation bias, and it's something that we need to avoid, because the thing is that our brain is basically going to trick us into only seeing the data that supports the option that we favor, and our brain is just gonna block out everything else. So you need to basically be intentional about being critical to those options that you favor and actively go out and find opposing opinions, find opposing facts to that being a good idea so that you challenge yourself. And you can always pull someone into rubber duck and be that devil's advocate for you as well. But then there's also the relevance of that data, right? Another important angle that is sometimes forgotten is the relevance of the data. Now, in our industry, we follow the work of innovators and thought leaders and successful companies, and we look out for, the learnings that they share with us, and that is great. But it also comes with risks, because we're not going to build microservices like Netflix did. Or you know what? We're going to go full serverless like Amazon did with Prime. And then we're 18 months into our development cycle, only to read a new blog post that they released saying that they went back to a monolithic approach and actually saved a ton of money. Whoops. Now, first of all, it's important to nuance, right? Now, these articles are super, super valuable for us. There's a lot for us to learn from them. But the reality is, within your context, the odds are that you're probably not Netflix, Amazon, or Google, right? So it's important that you evaluate your own context and that you check whether that actually matches the context of the resource that you're referring to. Why did they move to a microservices architecture? Do you find yourself in that same situation, right? Are you building the same type of system? Are you even in the same line of business? Do you have the same scaling requirements? Now, this is also a mistake that I've made, and I see others make to this day, is just this wish or this desire to design for the over the rainbow expected scale. Oh, but we're looking to cater for hundreds of millions of users. Okay, great. How many users do you have today? Well, 100. And that's where this quote by Werner Vogels, the CTO of Amazon, really resonates with me. Because his rule of thumb has been that with every order of magnitude of growth, you should revisit your architecture to see whether it can support the next level of growth. So you have 100 users, okay, can you cater for 10,000 maybe? Would that work? Then you're fine. Have you hit, 5,000? And see if you can now manage 100,000 or 500,000 and build your way up as it reflects your needs. So it's important that you define your context and compare it to the context of the resources that you refer to, so that you can make sure that you're comparing apples to apples and not apples to watermelons. Now, bringing that back to the horror story, right? We can consider the following statement. Moving to Entity Framework Core from Hibernate is going to increase the application speed because it's so much more performant according to this article. Now, this is already a step forward because we are referring to some data out there. We're just not making that statement in a vacuum, right? And hopefully that article actually contains some benchmarking information and all of that. What is incredibly wrong with this is that it is not relevant to the problem that we're trying to solve. We are solving a compliance issue, not a performance issue, right? Because if we were solving a performance issue, we should be looking at completely different types of solutions first. And I would even say that as presented, this is an assumption. But what is an assumption exactly? Now, an assumption is basically a statement that we believe to be true. In our reasoning, we tend to build upon our assumptions so that we can take shortcuts and move a little bit more quickly. And that is basically hidden in our decision making. Now, I'm not saying that we shouldn't make any assumptions at all, but it's important to be aware of the assumptions that we are making. And actually, I think it's really valuable to explicitly call them out and write them down so that we can validate them and so that we can also reference them later. And one of the things I always like to say is act like a scientist. And why? Because I think, they're the best example of people who have the ability to question their core beliefs, right? That's what they do on a daily basis. That is really what their job is, to question everything and anything all the time over and over again. So yeah, whenever you find yourself in a meeting and someone makes a statement and everyone is nodding, even you are nodding, ask yourself, why am I nodding? Why do I think that this is true? And which data points actually support the statement to be true? Now, if I circle back to that previous statement made, we can now more clearly see that this is an unvalidated assumption. Because even if Entity Framework Core is actually faster, we don't know what's the performance gain per request. Is it nanoseconds, milliseconds, seconds? Now, the benchmarking results in the article are now assumed to just apply to our application. But we haven't actually tested that. And maybe if we would implement it, our application may end up slowing down because how we're doing certain other things, right? So we can't really safely make this assumption. It's a risk, which brings me to the risks that are also associated with our decision making. Now, a risk that is always applicable to any type of decision that we make is that any of the assumptions that we make within our decision making turns out to be false. Now, that's also why I find it so important to explicitly call out those assumptions, because it's a really powerful way to surface any risks that we may be facing as well, right? Beyond that, also spend some time trying to identify and quantify potential risks, right? These could also come from very different sources, even for software. They could be of the technical kind, like complexity or technical debt or scalability, but they could also be of the operational kind, like, for example, downtime is required, or we can't adhere to certain SLAs, or procedural like GDPR compliance or something like that, but also financial, affecting ROI and budgets, reputational, or even human, maybe affecting our staff, for example, right? But how exactly do you quantify risks, especially in a field like software, right? It's not that we find ourselves in a financial type of environment where we could just add up numbers and that would reflect the risks that we're facing. Now, I've actually looked into quite a multitude of different strategies, and I think there are a lot of valuable ones. I have a bunch of them listed in my resources at the end, but the one that I seem to gravitate towards the most is actually the risk assessment matrix. In this case, we're going to look at, how probable is it that this risk actually becomes true? And what would be the severity of the impact if that risk becomes a reality? And then you would plot that out onto the matrix, and it would give you an indication of whether it's insignificant, medium, low, or high. And that would give you a sense of, how seriously should I take this? Now, again, we can apply this to the horror story, and we could come up with a couple of ones, right? This will increase the code complexity, possibly cause bugs if we do it in an incremental manner. We're migrating a fully functional code base, right? So this is going to take time. It's going to cost us money. And this migration will require feature freezes so that we can isolate changes in complexity, also affecting new features that we're unable to deliver. But finally, the biggest risk is we haven't spiked or thoroughly analyzed this. There are so many unknown unknowns that if you would just plot out that one risk in the risk assessment matrix, it would probably turn out to be a big red one. But okay, now we have all of the required building blocks to look at each of the individual possible solutions that we may look at, right? But we also need to structure how we work on those alternatives. And one of the things that I like to stress, especially when you're working collaboratively in teams, is that each alternative has to be looked at on an individual basis. And we need to refrain from engaging in any trade-off analysis early. Just look at each alternative in isolation, look at its assumptions, look for data, look at its risks. And once all of that is done for all of the alternatives, then start comparing. There's no need to introduce that complexity already early on. And then we're finally ready to propose a decision. Now, at this point, we've understood the problem, point one, right? We understand who it affects and which needs it would address. We have considered multiple alternatives, backed them by data, validated our assumptions, quantified risks, and then we have a way more structured way to propose a decision. But for that proposed decision, we still need to circle back to our risks and ask ourselves, okay, we have those identified risks. We know how severe they could be. So what do we do with them? Should we accept them? That could be a solution, but accepting them is not the same as ignoring them. If you're accepting risk, you should have a way to track data points to understand whether that risk is becoming a reality. But if you can't afford to actually accept the risk, then you need to understand how you're going to manage them, right? Is there a way to reduce it? Is there a way to entirely mitigate it? Now, some of you might have been reminded of architecture decision records as I'm talking through this. Now, an ADR or architecture decision record documents a specific software design choice that is architecturally significant, and in its simplest form, it captures the current status, the context, the final decision that was made, and the consequences. Now, there are a couple of sophisticated templates available, and I could see an argument made for comparing that process to ours as well. But I would say that there's one key difference. There are a couple, but one key difference that I haven't mentioned up to this point, and that is feedback. Because although I've left it out up until now, feedback is really the backbone of our process, of our decision-making process, and that's also why we call it an RFC, a request for comments. What happens is that RFCs are published to the whole organization. If you have a huge organization, maybe that may be a smaller portion of the organization, and that remains open to feedback for a period of time. Anyone can read this, right? It doesn't matter what role you have or how much seniority you have in the organization. You can read it, you can chime in, you can share your feedback and your own thoughts on that. And it's not only that, it's actually that we highly, highly encourage it. We welcome everyone to share their opinions. Now, of course, the risk with allowing feedback from everyone is that sometimes we disagree, right? And that's fine, because the goal of this process is not to create alignment on the decision. The goal of this process is to validate the decision making, right? Did we miss any viable alternatives? Did we actually validate our assumptions? Did we quantify all of our risks? If we haven't done that, we need to go back to the drawing board. And that helps basically improve the quality of our decision making, because it's also out there for everyone to review. Now, this also means that we don't only structure the decision making, but we also structure the feedback, right? Because if you review such an RFC, you also require some level of critical thinking, because you look at something and your reaction might be like, oh my God, this is a terrible idea. Why are you going to do this? But it is then your job to basically translate that gut no reaction to, what did they miss here? Did they miss an alternative? Did they miss an assumption, or is there an assumption that is false? Did they miss any risks? Are they quantified correctly? And the thing is that if we can't bring it back to anything like that, then you can't really poke holes in the decision making. And even when we disagree, when we understand the reasoning, that naturally creates already an alignment. Now, with all of that being said, there also has to be a balance. Now, if it wasn't clear by now, this is not a lightweight process, right? It takes a lot of time to assemble the pieces, to present this to an audience, to process the feedback. So it's also important to understand when lighter weight processes make more sense. And that's where it becomes important to differentiate the smaller decisions from the big ones, right? And one powerful way that I find to differentiate is to ask yourself, if we would just go with any option for this problem, how easily would that be reversed? Not only tomorrow, but in a week, in a month, and in a year. And that will give you a sense of how impactful that decision is and whether it would benefit from a more structured decision-making approach as well. But that being said, as you engage more in that structured critical thinking, your critical thinking skills are improving, and that is also going to shine through on any of the small decisions that you make as well. If to this date you haven't really structured your decision making, then this might just sound incredibly overwhelming. That's why I think it's important to tell you that we also just didn't introduce a process like this big bang from day one, right? And I wouldn't recommend that you do either. This is something that has been iterated and refined and expanded as we went on, and it can be introduced step by step. What I'm presenting today is basically the compounding effect of all of that work. But you can start slowly. I would say start with understanding the problem. Start with writing things down so that you at least have a track record of your decision. Use those architecture decision records, for example, in their simplest form. And step by step, you can improve your critical thinking. So to recap my session, this critical thinking is something that you practice. It's not something that you're born with, it's something that you can learn. It's important to work collaboratively with a diverse group of people to improve that critical thinking, to get different perspective, and start by clearly defining the problem. That's incredibly impactful by itself, and structure your decisions around multiple alternatives, risks, assumptions, and supporting data points, and start small and keep on iterating over that. Thanks a lot for listening. If you scan the QR code available, I have some additional reading material for you. And yeah, I'd be happy to hear any additional questions, whether it's on the chat that I'll check later, or maybe online as well if you'd like to connect.
Well, thank you for this insightful session, and of course for all of those interesting suggestions. And there are a couple of questions. First question is, are there any leads to manage a situation if stakeholders impose solutions where hardware cost is low, but leads to, in turn, complex software solutions and more effort in software design?
Okay, well, again, then that's going to be a case in which you will have to explain to them and basically try to gather, again, all that data and all that facts to show them that actually they're just moving the cost of having more expensive hardware to having a lot more expensive and complex software, and how that compounds. Now, I think the tricky part with these types of problems really doesn't even come from the amount of money that we're spending, but just from how organizations work and how bookkeeping works, really, because staff is a completely different cost, and it's translated very different in an organization's financial numbers than hardware costs. And I think a lot of the friction also comes from that, but even calling that out by itself can already be powerful.
Yeah, thank you very much. And I believe people really enjoyed the elevator reference, and there's a question about that, although it's a bit of a fun question, but still, is it required to take the elevator?
That's a really good point. But I guess it depends. If you're, I don't know, in Dubai and you have to go up the skyscraper, I'd rather take the elevator.
Yeah.
So it's an it depends question, as with everything in our industry, I'd say.
Oh, and someone else is asking if it is possible to post the link of the QR code in the chat. Can you do that? Do you I suppose you have access to...
Yeah, I can do that once I hop off, and I will share it. I will also share it again on my LinkedIn or Twitter if you're following me there, so that you can get access to all of the resources. There's a bunch of reading material there, as well as a more in-depth article actually on the slow elevator, which is a really, really powerful read about problem reframing.
Okay, thanks. So also the slides will be available after the session, just so you know. Oh, there's another question, and we have a couple of minutes left, so...
Yes, it's done on purpose.
Who typically organizes the process of structuring feedback, and how do you organize this in an organization with a few hundred people?
Right. So what we've basically done is, a lot of it really comes back to the organizational philosophy, right? So we already have it in our organizational philosophy to basically value everyone's opinion. So that also has to be ingrained in how the organization behaves, in how your people behave. But when it comes to the RFC process, let's say that you're presented with a possible decision, right, with a recommendation that came from a group, you are forced to basically point out, oh, but you missed this alternative, or that risk is actually not quantified correctly, or that is missing. Because otherwise, the group that is basically proposing that decision can just ignore your feedback at that point. So it's in your best interest as a reviewer to structure your feedback, because if it's just, I disagree, well, honestly, if you put yourself in the position of the group that prepared that decision, how do you deal with that without additional context, right? That's why it's also so important to structure the feedback. So there's a responsibility on two ends there.
Okay, yeah, that makes a lot of sense. Thank you. And I believe, yes, that was the last question. So thank you very much for being here today. It was a pleasure having you.